Welcome back to our channel. Today, we are diving into an exciting topic, implementing facial recognition for crowd analysis. This fascinating field of computer vision can provide valuable insights for various applications, such as security, marketing, and demographic studies. We'll explore how to use Java along with some powerful libraries to accomplish this. Let's get started. First, we'll set the stage by discussing the main components required for our project. To implement facial recognition, we will need a few essential libraries: OpenCV for image processing and face detection, as well as a machine learning library like Deep Learning for Java, DL4J. Before we dive into coding, make sure you have Java Development Kit, JDK, and Apache Maven installed on your machine. If you haven't installed OpenCV yet, head over to the official OpenCV website and download the Java bindings. Next, we need to set up the Maven project. Create a new Maven project in your IDE and update the pom.xml file to include the necessary dependencies. This is how your pom.xml should look. With the dependencies set up, let's initialize OpenCV in our project. We'll create a new class called Facial Recognition. Here's how to load the OpenCV library in the main method. Now that we have OpenCV initialized, we can start processing video input to detect faces in a crowd. First, let's set up a method to capture video from a webcam. This method will utilize the video capture class from OpenCV. Let's integrate this method into our main workflow. We should call the start video capture method inside the main method right after initializing OpenCV. Next, we need to detect faces in the frames captured from the webcam. For this, we will use OpenCV's HAR cascades for facial detection. Let's create a method called detect faces that will take a frame as an input and return the list of detected faces. Now that we have a method to detect faces, we can apply this to each frame inside the start video capture method. For each detected face, we can draw a rectangle on the frame to visualize the detection. Let's update our while loop accordingly. This brings us to the next step, displaying the processed frame with the detected faces. We'll use HiGUA.imshow to achieve this. Modify your loop as shown below. Now, let's talk about processing the detected faces. For crowd analysis, we can count the number of faces detected in each frame and collect this data over a period of time. Let's create a method to count faces and display the count on the screen. We integrate the face count display in our video processing loop. Add the following line right before displaying the frame in the while loop. You might notice that our program is now capable of detecting faces and counting them in real time. However, crowd analysis can go beyond just counting. For example, distinguishing between different individuals using facial recognition requires more intricate analysis. To implement facial recognition, we'll train a model using deep learning techniques. This can be a complex topic, but don't worry, I'll guide you through it. Let's start with preparing our dataset. You can gather multiple images of individuals in different lighting and angles. Once you have your dataset, we will use a pre-trained model from DL4J. You can leverage the face recognition model provided by the library. The first step is to configure your neural network. Here's an example of how to set it up. In this configuration, we need to customize the number of inputs, hidden nodes, and classes according to your dataset. After defining the network architecture, we should train our model using the labeled images in our dataset. Remember, training a neural network can take time, especially depending on your dataset size and the complexity of your model. Make sure to validate your model periodically using a separate validation set to prevent overfitting. Once your model has been trained, you will want to integrate it back into your real-time video processing. You can do this by iterating through detected faces and passing each region of interest to your trained neural network. You might need to adjust the pre-processing steps depending on how you designed your model. For instance, resizing the image to match the input shape expected by your model, normalizing pixel values, and converting the image to the correct representation. As you become familiar with the facial recognition aspects, consider expanding the project to include demographic analysis, such as estimating age and gender from the recognized faces. You can find pre-trained models available for those tasks as well. Now that we have discussed the core concepts and implemented our foundational code, it's time to consider how to handle application performance. Running real-time recognition will require optimization. Some performance improvements could include reducing the frame size, processing only every nth frame, and adjusting the confidence threshold for facial detection. Here's an example of how you might only process every second frame. At this point, you should have a base application capable of facial recognition for crowd analysis using Java and some powerful libraries. Test your application in real scenarios and observe how it performs under different conditions. As we reach the end of this tutorial, I encourage you to explore other features related to video analysis, such as tracking individuals over time or clustering detection according to demographics. The future of computer vision is incredibly promising, so stay curious and keep experimenting. Thank you for joining me today. If you found this video helpful, please give it a thumbs up and subscribe for more programming tutorials. We'd love to hear your thoughts or questions in the comments below. Until next time, happy coding!